Which of the following actions would increase the rate of the substitution reaction shown below? So we are told in this question that we are dealing with a substitution reaction. So we have two possible pathways for substitution. The Sn1 pathway, which is the stepwise pathway, and the Sn2 pathway, which is the concerted substitution pathway. The major determiner of which of these two pathways is taking place is the structure of the alkyl halide. We tend to see the stepwise process when we have a tertiary alkyl halide that can form a stable carbocation. The concerted pathway takes place with our less hindered alkyl halides, things like methyl, primary, and secondary alkyl halides. And so looking at our starting material, we have a tertiary alkyl halide. So that tells us that this reaction is going through the Sn1 pathway. So the Sn1 mechanism is the stepwise mechanism. So the first step of this reaction is that it is going to ionize. So we are going to lose the leaving group, forming a tertiary carbocation and the chloride ion in this case. This first step is the slow step. This is the rate determining step of this reaction. And so the rate law for an Sn1 reaction is the rate is equal to a rate constant times the concentration of the only species that is involved in that step, which is your alkyl halide. So if we're looking at increasing the rate of substitution, one thing that we could do would be to increase the concentration of tert-butyl chloride. So let's take a look at our options. So option A talks about doubling the concentration of water. Well, water is probably already in a large concentration here. It is functioning as both the nucleophile and the solvent in this reaction. And so we call a reaction like this a solvolysis reaction. And it's not involved in the rate determining step, so that's not going to help increase the rate of this reaction. Decreasing the concentration of the alkyl halide would actually decrease the rate by half. Doubling the concentration of tert-butyl chloride, that would increase the rate of this reaction.